Supercomputers can enable amazing research and scientific discoveries, but they require a sophisticated coordination of application codes, diverse underlying hardware, and system software. Efficient systems can process more user requests and improve the pace of scientific discovery. And understanding power and energy costs enables better utilization and more environmentally friendly practices. Opportunities for optimization exist at all levels in a supercomputer's software stack. Power-aware job schedulers, runtime systems, as well as large-scale monitoring frameworks allow for balancing power between multiple users as well as different tasks of a parallel application. We refer to such interoperable power-aware software stack as a power stack. These optimizations at multiple levels can only be made possible with the help of dials that exist at the lower compute node level. Some examples of such dials include ones that allow for measurement of energy and temperature, or for managing CPU, GPU, and memory power. However, these low-level dials vary significantly across vendors and can be incredibly complex to understand and tune. The Variorum library provides users with easy access to these dials in a vendor-neutral manner and has been successfully integrated with higher levels of an interoperable power stack.
Supercomputer users have diverse backgrounds and include system administrators, application and domain scientists, and research software engineers. Most commonly, users are not familiar with low-level architecture details across the different vendors, and some power and performance dials require the user to have elevated privileges. As a result, accessing power and performance dials that are complex and vendor-specific can be chaotic, unwieldy, and error-prone from the user's perspective. Variorum's Application Programming Interface, or API, abstracts out the details of the vendor-specific implementations and makes dials available to both general and advanced users in a portable manner. These dials allow for measurement and control of various physical features of the processors and accelerators, such as power, energy, frequency, temperature, and performance counters. Currently, we support several different vendors and multiple generations of their microarchitectures.
Here is a demonstration of Variorum in action. The user queries the power usage of the CPU and the GPU on different underlying architectures using the high-level vendor-agnostic Variorum API. We have successfully integrated Variorum with production-level system software in the power stack. Variorum interfaces with other system software designed for job resource management such as Flux, runtime systems such as GOPM and COCOS, and monitoring software such as Caliper and the Lightweight Distributed Metric Service, or LDMS. Variorum not only provides power management features for system-level software, but it can also enable scientific applications to directly monitor system power during execution. For example, the multi-scale machine-learned modeling infrastructure, or the MUMI workflow, which is an award-winning workflow for cancer research on Sierra supercomputer, can interface with Variorum at both the simulation level as well as the Flux job manager level.
The problem Variorum solves is not only the total power of an exascale machine, but also its dynamic power behavior. All other compute nodes, for example, include multiple GPUs, resulting in significant power fluctuation during application runs. To address this, we have developed a driver for node-level power management, which has been integrated into Variorum. Variorum's vendor-neutral API is highly valuable to the HPC community.
Variorum is open source and is available through GitHub. It benefits from contributors across industry, national laboratories, and academia, such as Argonne National Laboratory, IBM, and AMD, among others. To support the open source community actively, the Variorum development team regularly organizes workshops, tutorials, and presentations. Our documentation website also provides instructions and examples for easy access to our users.
So why the name Variorum? The term comes from the practice of collating variants found in early editions, particularly early printed books. For example, Shakespeare's plays have a number of variants both within and across editions. A collection or an edition that has these is called a Variorum edition. Likewise, our Variorum software library collects variants in interfaces and best practices for low-level hardware features across multiple GPU and CPU architectures. Pushing our supercomputers to their limits requires getting closer to the metal than standard software and operating systems allow. Variorum provides robust, portable interfaces that allow us to measure and optimize computation at the physical level: temperature, cycles, energy, and power. With that foundation, we can get the best possible use of our world-class computing resources, from purchasing to runtime systems to job scheduling.